Hi peeps, this is Mrs. Tootin. This is from the chemical reactions packet, page 12. We're going to go through how to determine all of these reactions, whether they're a synthesis, a decomposition, a single replacement, double replacement, or a combustion. Remember these 5 types of reactions. Remember that a synthesis reaction is when you have 2 things, like thing A and thing B, and they synthesize together. They form together. They get made together. The reaction puts them together. So you have one thing. Instead of A and B separate, you have A and B together now. And a decomposition reaction is the exact opposite. Decomposition means to decompose, to break down. And so instead of making AB, you start with AB. So you start with this thing that's already together, and when the reaction happens, AB decomposes. AB undergoes decomposition. It breaks down into the 2 parts. So synthesis and decomposition are the opposite. Single replacement, sometimes called single displacement. Single replacement is when you have something like A is sitting all by itself, and it reacts with a compound that has 2 things together. And what happens is the A reactant, it kicks the B out. These are usually 2 metals. So the A kicks the B out, and A bonds with C. It replaces the B. That's why it's called a single replacement, or displaces, single displacement. So instead of B being with the C, the A is with the C now. And where the B go? The B got kicked out and is by itself. So basically the A and the B switch places is what happens. That's what a single replacement is. A double replacement is very similar. It's just a double switching. So at first, and on the reactant side, A is with B and C is with D. But what happens? The A and the C, they're going to switch places. So instead of A being with B, A is going to come and kick C out, and A is going to be with D now. And who's going to be with B? C's going to be with B. So that's a double replacement. A double replacement often looks very confusing. There's usually a lot happening in a double replacement, but it's just as simple as a single replacement. And then the very last one, the combustion. A combustion reaction is technically any reaction that has oxygen as one of the reactants. And technically anything can react with oxygen to form anything else. A lot of the time we usually talk about some kind of a carbon-hydrogen compound reacting with oxygen. And if a carbon-hydrogen compound reacts with oxygen, then the thing that gets made is carbon dioxide and water. So combustion, that's a combustion. All right, so let's do this page. What I'm gonna do is I'm gonna first go through this whole page, and I'm gonna do the easy ones first. I'm gonna, if we think about this document as, or these types as kind of being separate, synthesis and a decomposition are just opposites to each other. I'm gonna look for them first. So synthesis is when one thing gets made. So check this out. So number 1, there it is. One thing's getting made right there. So that's a synthesis. Number 2, 1, 3, 4. There we go. One thing's getting made, aluminum oxide. That's a synthesis. Number 5. 2, 2. Here we go. Number 7. One thing getting made. That's a synthesis. 8, 9. There we are. Number 9. One thing getting made. Sodium iodide. That's a synthesis. 10, 11. Look at 11 and 12. One thing getting made. sodium oxide and hydrochloric acid. Those are both synthesis. And by getting made, I mean on the right side of the arrow. Remember, the things on the left side of the arrow are called reactants, and the things that you make on the right side of the arrow are the products. So right now I'm just quickly looking through the products. Okay, two things, there it is, one thing getting made, that's a synthesis. One thing getting made, that's a synthesis. By the way, this can be a little bit more complicated than I'm making it. I'm just making this very simple. Two things. I'm gonna skip these guys for a minute. All right, so that's all my, well, actually, let's do it. Here we go. No, I'm gonna skip them for a minute. Okay. All right, so that's all the regular synthesis ones. So let's look for the decomposition ones. Decomposition is the opposite. Decomposition is if I'm just starting with one thing. If you're starting with one thing and it breaks down into pieces, that's a decomposition. It decomposes. So starting with two, there it is, number 6. Starting with one thing, sulfuric acid, and it breaks down into pieces. That's a decomposition. Two things, because the plus sign, remember that means there's two different things, this thing and that thing. Number 10, this thing and that thing. There it is, number 13. Just one thing on the left side of the arrow. Carbonic acid. So that's a decomposition. Two things. There's one thing. Calcium hydroxide. So that's a decomposition. Two things. There's just one thing. That's a decomposition. Okay. All right, now let's look for the replacements reactions. So single and double replacement. Single replacement, remember, it's one thing kicking out another. But the key for a single replacement is this guy is single all by himself. Kicks B out, and now B is single all by himself. Okay? So let's check that out. So here we go. In number 2, there's bromine all by itself, and it's gonna kick out the oxygen, and now we have oxygen all by itself. So that's a single replacement. So is number 3, magnesium all by itself, and the magnesium comes in and kicks out the hydrogen, and the hydrogen's all by itself. And so instead of hydrogen being with chlorine, now magnesium's with chlorine. So that's a single replacement. Number 5, there's nothing by itself. This is potassium and bromine. This is hydrogen and sulfate. Again, nothing by itself. Nothing by itself. Number 14, it's nothing by itself. Number 18, there's zinc all by itself. Zinc is all by itself. It comes in as kicks the lead out. See, the lead gets kicked out by itself. So that's a single replacement. Number 19, same thing. There's aluminum all by itself. I know there's 2 aluminums, but when I say all by itself, I mean it's the only element. It's a pure element by itself. It's not bonded to anything right now until the reaction happens. When the reaction happens, you can see the aluminum comes in and reacts and kicks the hydrogen out, and now the hydrogen's out by itself. And instead of the aluminum being alone, the aluminum is now bonded with the chlorine. So that's a single replacement. So let's see. We're coming near the end of this. We only have double replacements to look for and combustions to look for now. Double replacements are, one easy way to find them is sometimes they're just big and complicated looking. And plus we don't have very many left. So let's see what's a double replacement. If we look at number 5, we haven't answered that one yet. That is a double replacement, and look how big and gross it looks. And if you look at what's happening, see this let me get a different highlighter. See this potassium? The potassium and the hydrogen switch places. The potassium's with the bromine now, but it switches. The potassium, instead of being with the bromine, the potassium's now with the sulfate. And and now the hydrogen's with the bromine. So that's a double replacement. There's a double switching. Number 8 is also a double replacement. The sodium is bonded to the sulfur and the hydrogen is bonded to the chlorine, but they switch places. Instead of the sodium being with the sulfur, the sodium is now with the chlorine. So that's a double replacement. Okay. And then number 10 is also a double replacement. The sodium and the silver are going to switch places. Instead of the sodium being with the chlorine, the sodium's going to switch and be with the nitrate. So that's a double replacement. Let's keep going. Is this one a double replacement? First, ask yourself, is it big and scary looking? It's probably a double replacement. And if we look at it carefully, it is. Sodium is with sulfate and barium is with chlorine, but they switch. Instead of sodium staying with sulfate, sodium switches and the sodium's with the chlorine now, and the barium's with the sulfate. So this is also a double replacement. Okay. Now, before I get to these guys at the bottom, I do want to say one more thing, and that's because notice we did all 20 and we didn't do any combustions. The fact of the matter is, remember I said that technically anything that reacts with oxygen is a combustion. It doesn't have to be a carbon-hydrogen product compound making carbon dioxide and water. It can be anything reacting with oxygen, making anything else to anythings. A combustion reaction can be complicated. The key to a combustion is that one of the reactants is pure oxygen. And if we come down and look, no pure oxygen, right here, see that? Remember we classified this as a synthesis, but technically, because of that pure oxygen right there, we could technically call this also a combustion. Pure oxygen, there's another one, pure oxygen. We could call this a combustion also. Let's see, oxygen. I'm not looking for oxygen bonded with things like this nitrogen. I'm looking for pure oxygen right there, pure oxygen. Pure oxygen, if pure oxygen is on the left side, if it's one of the reactants, then it's technically a combustion reaction. So number 11 can also be called a combustion. Pure oxygen, there we go. Here, 15, pure oxygen, that could be called a combustion. Pure oxygen, 17, pure oxygen. I know there's 5 of them, but it doesn't matter. It's pure oxygen. So that could be called a combustion, and that's it. Okay, the very bottom, have you taken a look at these yet? These are kind of fun. Because the fact is, it doesn't matter. Doesn't matter what your symbols are. So if we look at this first one, we have 2 things. These 2 smiley faces are bonded with each other. But then what happens to them? They break apart. See that plus sign? So if you have one thing that then breaks apart, that's a decomposition, one thing breaking apart. And then number 22 is the exact opposite. See the plus sign? You have two things here. And what happens in the product? They form together. They bond together, forming one thing. When you form just one thing, that's a synthesis. Number 23, if you look at it, number 23 looks a little bit more complicated, but 23 is exactly like 22. One thing and another thing. Even though there's three of them and there's these little subscripts, I'm just looking at the thing. In this case, a spade and a heart. If you look at them, the spade is all by itself and the heart is all by itself. But what happens? They bond together. Spade and heart bond together. And so when you form just one thing, that's a synthesis. Number 24, if you look at this, we have three different things. We have smiley face all by himself. Then you have single note and double note. And what happens? The smiley face comes in and kicks out. See that? The smiley face comes in and kicks out the single note. And because the single note used to be bonded to the double note, but now the smiley face is bonded to the double note. So the smiley was alone, but now single note is alone. So when you go from one thing being alone to a different thing being alone, that's a single replacement. One thing being alone to a different thing being alone. So this one's a single replacement. And then the last one's a double replacement. You can see we had this clover was bonded to this spade, and the heart was bonded to the diamond. But what happened? They ended up switching places. Instead of the clover being with the spade, the clover's now with the diamond. So that one's a double replacement. And then the last thing I'm going to say, and maybe you already noticed this. Did anybody notice the situation for number 22 when I did it? Number 22, remember we said was a synthesis because you made just one thing. But number 22 is actually also a combustion because there's pure oxygen there. So we could also call that a combustion. So that's it. That was a long one. This is a little bit hard, but with practice, you'll get really good at it. And you're going to email your teacher when you have questions. All right. Have a good one. Talk to you later, peeps.